All right, let's get into some properties of logarithms. So we've introduced logarithms so far, and eventually we want to use them to solve problems. But between the introduction and the application, we're going to have to come up with ways of working with them, ways of moving them around, combining things, separating things, stuff like that. And that's what this section is all about, okay? We're not going to do anything useful in this whole section, okay? It's just practice, moving things around, but we're not going to solve anything or really make anything go crazy. It's just practice. We're getting these logs to do what we want them to do. So we're going to start with a little recollection. One of the most important things in this whole chapter is that logarithms are the inverses of exponentials. I said I'd say it a bunch, and I'm saying it a bunch. All right, so specifically what that means is if I have an exponential function with a base b and another function that's a logarithmic function, again with base b, that these are inverses. And we had a lot of cool properties about inverses, right? Specifically, function composition. If I have the function composition and their inverses, then it just equals x. And it doesn't matter which order you do the function composition, as long as f and g are inverses, and in this case they are, the exponential and the logarithm cancel each other out. And that's one of our first properties. Our first property of logarithms, the inverse property, says that f of g, b raised to the exponent of log base b of x, that exponential and that logarithm cancel each other out, and we're just left with x. And similarly, log base b of b to the x, these are also inverse functions, just in a different order. They cancel each other out just to x. Okay? And that's the inverse property. We'll talk about the product and quotient rules soon, but let's use this a little bit with an example. Example 1. Simplify with the inverse property. Part A wants us to simplify 6 times the common log of 10 squared. Now, we already know how to simplify this with previous methods. We could just look at this logarithm directly and then convert it to exponential form and then multiply our end result by 6. But let's use this property. Notice, I tried to fix that 2. That 2 cannot be fixed. This is exactly the property that we had before. As long as the base of the logarithm and the base of the exponential are the same, then the logarithm of an exponential is going to cancel. This just becomes 6 times 2. So this isn't exactly what's happening, but it's kind of like this. They're canceling in that way. All right. So just like that, the answer is 12. We could do a couple more. 2 plus the log of 1,000. Same situation. Now they cancel, but it might be a little hard to see how they cancel unless we rewrite it. This is log base 10. What's 1,000? 10 cubed. So if you write it like this, then it's much easier to see where it comes from. Log base 10, write that as 10 to some exponent. All right. So again, that's just going to cancel, and we're going to get 2 plus 3, which is 5. And we could do one more little practice. Log base 2 of 8 plus log base 9 of 3. And it's the same idea. Write that inside in terms of the base. So what is 8? 8 is 2 cubed. These are going to cancel. What is 3? Wait, how do we write 9 to what exponent is going to be 3? It's the square root of 9 is 3. So 9 to the 1/2 power. Watch out for those fractional exponents especially. And then we get cancellation and we'll just get 3 plus 1/2. That's going to be 7/2 or 3.5. All right, this step specifically in this one can be a little tricky. We're just rewriting the 3 so that we can use this inverse property. All right, let's introduce the next property. But y'all are going to have to work for it. All right. Let little m be log base b of big M. And similarly with little n. We're going to figure out where the next property comes from. Part A. Convert both to exponential form. We have pretty good practice doing this by now. Converting to exponential form is one of the best ways, or most straightforward ways, to evaluate logarithms when possible. So let's look at this first one first. The base of the logarithm is the base of the exponential function, b. The input of the logarithm becomes the output of the exponential, and the output of the logarithm becomes the input of the exponential function. And we can do the same thing with the other one. B to the little n equals big N. So the red is the same thing as the red, and the blue is the same thing as the blue. These are equivalent, exponential and logarithmic form. Well, let's use that now to do part B. Simplify log base b of m times n. Well, how do we do this? Well, let's convert this to exponential form. Okay. Well, actually, let's do it even simpler, right? Let's substitute, right? M is b to the little m. N is b to the little n. So this just becomes log base b of b to the m times b to the n. And we want to simplify this. Well, maybe we don't know a lot of properties about logarithms, but we do know properties of exponents, right? We can simplify this inside. If we're multiplying two exponential functions that have the same base, we just add the exponents. It becomes b to the m plus n. And now we can use our inverse property. The logarithm is the inverse of an exponential, so the logarithm of a single exponential is going to cancel, and we're just left with little m plus little n. What was little m? Little m was the log base b of capital M, and the log base b of capital N. So these logarithmic properties we're introducing in this section are just the properties of exponents. Think about a logarithm as an exponent, right? If I go off to the side and say, how do I evaluate log base 3 of 9? Well, I say, okay, this logarithm is equal to some number, convert it to exponential form. Notice that the logarithm is that exponent. Right? This logarithm equals some number n, and n is the exponent that we're looking for. Logarithms are just exponents, so the properties of these logarithms are just the properties of exponents. If I multiply two exponential functions, that means we add the exponents together. So the logarithm of two things on the inside is just going to be adding those exponents together, adding those logarithms together. All right? And this is the product rule. There's a very similar one for the quotient rule. Let's write them down. Product and quotient rules. Product rule is exactly what we just wrote down. Log base b of m times n is just the sum of their individual logarithms. Quotient rule is very similar. M divided by n. We're dividing exponential functions. What do we do with the exponents? We subtract them. So this is going to be log base b of m minus log base b of n. And those are the next two properties and the final properties we'll talk about in this video. Let's do some examples with this. 2 examples, and then we'll be done. Example 3, separate or expand. Like it's the same word. You can use either word. We're going to try to expand these logarithms. And part A is log base b of 3x times 3y. Again, expanding these logarithms doesn't necessarily make things simpler. It's like the difference between factoring and foiling or distributing. One's not necessarily always simpler. Sometimes we want things factored, sometimes we want things distributed. We have to get practice doing both. That's what we're doing here, practicing. We're going to use the product rule. Product rule says if I have the logarithm of 2 things multiplied by each other, that's just their individual logarithms added up together. So this is the logarithm of the first piece plus the logarithm of the second piece. And in fact, we can separate it even more, right? This is m times something else. 3x is just 3 times x, so let's do it again. Let's separate this as much as we can, just to get some practice working with logarithms. This becomes log base b of 3 plus log base b of x plus log base b of another 3 plus a log base b of y. And now things are fully separated. There's one more thing we can do though. Combine like terms. We have a log base b of 3 and another log base b of 3. Add them together. Now we've got 2 of them. So we have 2 log base b of 3s plus the log base b of x plus the log base b of y. Not necessarily simpler, but this is good practice expanding logarithms. And we'll see why in the next section, why we sometimes want to do that. And in the section after that, sometimes why we want to do the other stuff. Combining. Let's get some more practice separating. Part B, the natural log of 2x over y. Same idea. Let's use the quotient rule. Quotient rule says the logarithm of a quotient is the logarithm of the numerator minus the logarithm of the denominator. And now we can use the product rule on this first one to get the logarithm of 2 plus the natural log of x minus the natural log of y. This is the fully expanded out version of what we started with. Sometimes the combined form is nicer. Sometimes the separated form is nicer. Let's go the other way. Combine into a single logarithm. Part A. Log base 2 of 3 plus log base 2 of x minus log base 2 of y. Notice that we can only use the product rule if the bases are all the same. If the bases aren't the same, we're going to have to do something else that we'll talk about in the third video today. All right. But we do have the same base. It's log base 2 all the way around here. So I'm going to start by using the product rule. Let's combine these first two. It becomes log base 2 of their product, 3x. And we still have the log base 2 of y at the end. And now we can use the quotient rule. This is the logarithm of their product, of their quotient, 3x over y. And you can see that in 4a, we just did the opposite, the reverse of 3b. Let's do one more. log of x minus the common log of y minus the common log of z. Be very careful with these ones. Everything with a minus sign means denominator. Okay, but we can still do this in order, no problem. First two, quotient rule. This is the log of x over y minus the log of z. And now we're going to use the quotient rule again. It's going to be the logarithm of the first thing, x over y, divided by the second thing. Now we can simplify. All right, what is x over y divided by z? Well, that's the first thing divided by the last thing. Fractions just mean division. Fractions and division mean the same thing, so these are equivalent. X over y, change it into multiplication and multiply by the reciprocal. Division is multiplying by the reciprocal. We just get x over yz. So this whole thing is just a common log of x over yz, which looks really nice. Notice that everything with a minus sign is in the denominator. So after you do a bunch of these, you're going to see that this step can actually be kind of skipped because we know what we're going to get. If we got a minus sign, that means denominator, and you can kind of start combining them in a single step. We'll do that in video 4. Show how to work with some of the more complicated versions. But anyway, hope this helps and lets you get started. Let me know if you have any questions.